Hi, hello. So today let's continue our previous video. So in our last video, we talked about how to enable the either TLS SSO website blocking or XDP DNS blocking feature from the web UI. So this time, let's talk about how to actually block a website or a domain. So there is two ways, right? One is like you just block the DNS resolution to the website. Another one is you can just use TLS, SSO, or web block list, which is actually look into the SSO packet header to extract the server name indication extension to get the website domain name and then block it. So let's do the demonstration here. First, we can use the domain method. So here you can input your domain name, for example, ebpf.io, and let's add here. So now the ebpf.io domain name is in our block list. And so, for example, if from this client machine, if I wanted to do the DNS query to the ebpf.io and with the dig command, we will not get domain resolution. So this way we can block the website, right? And see here, collection timeout, no servers could be reached. So one of the other benefit for this solution is that in your home network or in your office network, if the client or the user put a third-party DNS server in their workstation, they can still not bypass this DNS block list. The reason is that as long as their network gateway is using this firewall, and on the firewall, for example, here, let me log into the firewall and look at the XDP program here. So we have this XDP DNS program attached to the Green Zero interface, which is your home network or office network internal network interface. So even if your client or workstation the configure third-party DNS name resolver, like here, if we so this is our workstation, right? And even if the configure like third-party DNS server, for example, if they use a public DNS domain server instead of your internal gateway DNS dummy servers, example this one, right? So they can still not bypass the DNS server. Okay, let me show you a command, right? We just use the dig. Okay, so here we used our internal DNS, our internal gateway IP, which by default is the workstation, is your client home network's DNS resolver server, and so here it is blocked, right? And yeah, we will get a timeout resolution, timeout collection timeout. So in some case, the user might put their workstation DNS server as like a public DNS server, and to bypass your internal DNS server. And so in that case, it still does not work. See, it's still not working. The reason is that the XDP program sleeve everything pass through this network interface, including the DNS request to the public domain server. So this guy will see everything for the DNS request, regardless of the DNS server the workstation use. So that's the benefit of using XDP DNS block feature. So if you are just using other features, other block feature like user space DNS block feature, if the workstation changed their DNS server, the block may not work. Okay, so hope I explained it clearly. And you can see here a collection timeout. No servers could be reached. Even the user use a public DNS server. Okay, so now we can remove this, and then the DNS server resolution should work, right? So use public DNS server works. Use local DNS server works. Oh, one, right? So works, right? Okay, so this is one way to block the website or domain. Now let's talk about this SSO. So what if we want to use this TLS SSO web? Let's put the same domain, eppf.io. Let's add it. So it's here. And let's use curl command to access the website. See here, it has a TLS handshake, but the XDP program here will extract the domain name, the eppf.io, from the client hello SSO packet, and will block it. See collection error timeout. Okay, but I'll show you it does not work with the Chrome browser. So this is Chrome browser, right? Let's type in the ebpf.io website, and it works. The blocking is not working, right? We can browse the website fine. So what's the problem here? Okay, the problem is I actually have a capture to show the problem. So when you use the browser, Chrome, from your workstation, your iMac, your modern computers with a Chrome browser or Firefox, the client hello. So here is the. So this is a client hello. Okay. This is a client hello packet, and you can see here the client hello has two TCP segments. So the first is the frame 4, and the frame packet 5 and the packet 4. So their total size, packet 4 has 1228 bytes. Packet 5 have 53 bytes. So this two packet size exceeded the MTU, the network interface MTU value. Then, so we have the at the bottom here, we have the extension server name with a value ebpf.io, and this extension server name it is in the second packet 5 payload. So it's in the 553 bytes. So when the XDP program parsing the client hello packet header, it recognizes packet 4 as a valid client hello packet, but so it will recognize the client hello handshake protocol and then do the client hello parsing, but it will not find this server name extension because this server name extension is not in the packet 4. It's not in the frame 4. Instead, it's in the frame 5. So when the XDP program passes the frame analyze the frame 5, the frame 5 does not have the handshake protocol client hello header. It only has the payload, like extension here with the just has the extension payload. It does not has this handshake protocol client hello. So the XDP program will recognize will think the frame 5 packet is not a client hello packet, and will just ignore the frame 5. So that's the problem, right? And so that's why it doesn't work. And there is a solution, like you can use Suricata here. Here is a Suricata forum, and you can use the Suricata IPS mode. Someone actually put the example here to use the TLS SNI feature to block the domain. and here you need to use the SSO state. So this can be a workaround with the XDP program limitation, and yeah, because the XDP program, it is only parsing the raw TCP packet. It does not track collection like the user space program Suricata does, or other like NGX or other web application. It has a stateful TCP collection tracking, so it can do the proper client hello SSO parsing. But for XDP program, it just sees the raw. It's just like a random packet. It is not even sync. It's a TCP packet, and so anyway, yeah. So that's the limitation here for the XDP program, and yeah. So if we remove this, we removed, and at least now our curl will work. So because curl, yeah, so curl will work, and because curl send the packet. Do I have a packet capture here? Let me see. Yeah, I don't have a packet capture here. Maybe I have here. (443) client hello. Yeah, so I don't have the curl capture here to just show you the example, because here also the client hello is segmented into TCP packet, because it's exceeded it exceeds the size of MTO, which is normally 1/500 bytes. Yeah. So anyway, yeah, this is how you can block a website with some limitation for the XDP TOS program. Yeah, thanks for watching.